Welcome to the Podkey summary of SwiftUI Group Lab from WWDC 2026. This one is a really useful SwiftUI catch-up, especially if you've ever felt like the framework was being a little mystical on purpose. The big themes are pretty practical. SwiftUI doesn't actually demand one blessed architecture. A lot of performance problems come from how broadly state changes spread. And several common habits that feel harmless can quietly make your app do way more work than it needs to. And once you understand the update graph under the hood, a lot of those weird re-render moments stop feeling random. One of the more reassuring points here is that SwiftUI is not trying to force everybody into MVC, MVVM, or whatever acronym is currently winning the argument online. Apple's position is basically, keep the architecture that fits your app, keep the storage layer that fits your app, and let SwiftUI sit on top of it. So, if you've got observable objects, existing services, older code, or a hybrid app that's part UIKit and part SwiftUI, you can adopt it incrementally instead of tearing the whole house down to replace the kitchen. A really important performance distinction is the difference between breaking a giant view into real subviews versus breaking it into computed properties that return views. A dedicated subview gets its own identity in SwiftUI's system, which means the framework can track what that subview actually depends on and only invalidate that piece when something changes. A computed property is more like an in-place helper. It's convenient, but it's still considered part of the parent view, so the parent is what gets reevaluated. That doesn't mean computed properties are forbidden. It just means if you're chasing performance, real subviews give SwiftUI more information to work with. That ties into the broader mental model here. SwiftUI is not walking the whole tree doing a browser-style DOM-diff every time you blink. Behind the scenes, it's maintaining a directed graph of view nodes and the inputs those nodes depend on. Updates happen because state changes. Then SwiftUI recomputes the nodes whose inputs changed. Once you think in those terms, a lot of the framework's behavior makes more sense. If a tiny state change causes a huge redraw, the problem usually isn't that SwiftUI is careless. It's that the state or dependencies are scoped too broadly. The environment is one of the easiest places for that broad scoping to sneak in. If you put a frequently changing value in the environment, every view that reads that key becomes a dependency target, even if most of those views don't really care about the new value in any meaningful way. So you can end up invalidating a lot of UI for what feels like a tiny update. A common fix is to put a stable, observable object into the environment instead, and let individual views read the specific properties they need. That narrows the blast radius. There are also a couple of habits that come up a lot in real code bases. One is using Geometry Reader for layout when the native layout tools would do the job. Geometry Reader can cause whole chunks of the hierarchy to reevaluate every time size changes, which is a pretty direct route to jank. Another is leaning too hard on change as a little trampoline, bouncing data around the app in callbacks. Sometimes that's necessary, but often it's a sign you're thinking imperatively in a framework that really wants the view to just be a function of data. The useful question is, do I need this callback, or could the view simply reflect the state directly and spare everybody the extra choreography? Two smaller patterns here are easy to miss because they look tidy on the surface. First, custom button wrapper views. A lot of people build their own button components just to apply styling, but SwiftUI already has button style for that. Using button style keeps the built-in initializers, keeps accessibility behavior, and avoids subtle bugs that creep in when styling logic gets duplicated in a bunch of wrapper views. Second, filtering inside ForEach with an if statement. It works visually, but SwiftUI still has to iterate the full collection. For large data sets, that's wasteful. Filtering before the ForEach gives the framework a cleaner, cheaper collection to work with from the start. If you move between UIKit and SwiftUI a lot, the layout model is worth keeping in your head because the direction is basically reversed. VA tends to lay out from parent to child, top down. SwiftUI reasons, bottom up, starting from leaf views and bubbling size requirements upward. That difference matters most in mixed apps, where size information and timing assumptions don't always line up cleanly. In those layer cake setups, a lot of confusion comes from expecting one framework to behave like the other. There was also a nice reminder that SwiftUI's lazy stacks and grids are not just a cute spelling variation on table views. They prefetch upcoming cells and can evaluate bodies off-screen, which reduces the need for the old UIKit obsession with manual cell reuse. That said, you can undo the benefit yourself if each view does expensive work in on appear or similar hooks. If setup is heavyweight, moving it into init or pushing it into background tasks preserves the advantage of that lazy pre-evaluation, instead of turning every scroll into a small negotiation with the CPU. On the tooling side, Content Builder, replacing the old View Builder overload maze, is a pretty welcome improvement. The practical win is fewer of those miserable expression is too complex compiler errors when view hierarchies get deeply nested. And it isn't only for SwiftUI views. It can also be used to build DSL style builders for custom types outside view code. Then there's concurrency. SwiftUI view code runs on the main actor, but some closures SwiftUI gives you are marked sendable and may run off the main thread. The safe pattern there is to capture copies of @state values inside those closures, instead of reaching back into mutable state and getting concurrency warnings. Most of the time, this only becomes noisy around animation or background-driven work, but it's one of those details that's boring right up until it ruins your afternoon. If you're trying to prove where re-renders are actually happening, there are a couple of good tools. You can drop in print changes to see which bodies are being recomputed, though that's definitely a temporary flashlight and not something you leave lying around in production. And the SwiftUI Instruments tool goes much deeper, with a graph view and flame chart that show what inputs triggered a body reevaluation. That's the kind of thing that turns a vague SwiftUI is slow complaint into an actual fix. Finally, on rendering performance, compositing group and drawing group do different jobs. A compositing group merges elements into a single layer, mostly for visual effects behavior, like shadows. A drawing group rasterizes an entire subtree into one bitmap, which can dramatically cut layer count and help frame rates in graphics-heavy interfaces like custom charts. The overall message here is pretty grounding. SwiftUI usually gets easier when you stop treating it like magic and start treating it like a system with clear inputs, identities, and costs. A lot of performance wins are less about clever tricks and more about giving the framework cleaner boundaries and less unnecessary work. Which honestly is also decent life advice if you squint at it. This episode was generated by Podkey. Create your own at podkey.fm.